mounting solution for just about any application out there. So some things to consider on some of these. We'll start off with the roof. So the roof is probably the most common. It also depends on what area you're in. In our area, the predominant roof for most residences are asphalt shingles. And then for ag and commercial, you do see some metal roofs. And then of course you get into the flat roofs, which I'll talk about at some point as well. With asphalt shingles, something to consider though, when you're thinking about putting them on the roof, is you're putting on a product that has a lifespan of 3 to 4 decades. And your roof is never going to last that long. So you have to consider what the cost is going to be to remove all that equipment and put it back up once the roof gets replaced. Now, it shouldn't be that big of a deal, but it is something to consider, and for the owner to be aware of that so that there's no surprises down the road. Generally speaking, if the roof is past half of its lifespan, which is going to be 10 to 12 years, depending on where you're at, depending on the roof shingle, depending on the color, depending on the pitch, all that good stuff, we suggest that we replace the roof before we put the solar on, to kind of reset the clock, as you may say. So that's something to consider. There's a couple different methods to actually physically attaching them. There are hanger bolt assemblies that, with a flashing mechanism, go into the roof truss itself, or purlin. And then there's deck mounts. We pretty much use mainly deck mounts. That gives us greater flexibility over the design and placement of the system. So deck mounts is exactly what it sounds like. They can be attached to trusses, or they can be physically attached to the plywood or OSB, and it works out pretty well. So those are the most common methods to attach. You are going to make penetrations in the roof. You're not going to get around that on an asphalt shingle roof. There's just no way. So, sorry, I'm driving. And so the other aspect is accessibility to the roof is a bit rough, right? So I mean, if you want to do any maintenance or need to replace anything, even want to clean them, it's a little more of a risky endeavor. We never suggest owners get on the roof at any time of the year to do any of those type of activities. We do offer O&M, operations and maintenance plans, to where we can come and clean the modules typically once a year, and let our trained guys handle that risk of it. So there's always that aspect of it. Sometimes pitches of roofs are not ideal for an installation. Orientation of the house is important. Some houses, majority of the good roof space is facing the wrong way. Now, we do get questions all the time about people think that the solar has to face south, and it doesn't. That's optimal, but we can mount them east and west and everything in between. We just don't want to install them northwest, northeast, or facing the north. That would not be very efficient. So there's definitely some flexibility there on what kind of roof that you have and the orientation and that type of deal. Other things to consider are the fire codes. Some AHJs, which is the authority having jurisdiction, which would be probably your city, your county, or possibly state, is going to chime in a little bit about the fire codes. And there are setback requirements on the roof, spaces along the edges of the roof and the valleys, hips, all that good stuff, for residential roofs anyways. And sometimes that eats up valuable space as well. So sometimes if you want to put up but something's better than nothing, right? So those are all things that you need to consider versus on a ground mount. It's more likely that you'd be able to get all the power you need, face it the direction that you want to go in, maybe optimal south, optimal tilt angle, all that good stuff. So there's some definitely advantages to that. The other aspect is on a roof is that a roof is already naturally very hot. So the hotter modules get the reduced power output that they have. Some modules are better than others for temperature coefficient. Like Panasonic has got the best temperature coefficient in the market, so that means that they're going to produce more power when it's hot out, which is a good thing. So those are all things that you need to consider. The pathway to get from the roof to the point of interconnect, which is going to be where you connect the solar to your existing grid system within the house, load center, meter, whatever. Those can sometimes be a challenge, whether it's a single-story home, two-story, basement's completely finished with drywall, and try to hide fasteners, conductors and conduit. It's a lot more difficult. Sometimes you have to mount this conduit on the outside face of the house or on the roof. So aesthetics sometimes is also something to consider, and getting that pathway without tearing into walls and making a big mess. So those are things that you all have to consider and you have to accept as a customer, depending on the situation. And then there's cost associated with that. So sometimes you can get all concealed wiring and that type of stuff, but sometimes it comes at a little bit higher cost because of the labor that may be required to be able to do that. So that's something that you just need to talk to your installer about, find out what the options are, and clearly understand how everything's going to look and the pathways, and for you to make an informed decision as to what you're comfortable with. Our personal favorite are ground mounts. They give some quite a bit of more design flexibility, right? So we could get an optimal tilt angle, azimuth, and they have a lot more airflow around them, so they'll stay a lot cooler, especially during the summer months, so they'll provide a little bit more power. They're a lot easier to maintain and to operate. So, for example, if we needed to do any troubleshooting or anything else like that, we could easily do that from the backside. On a roof, you'd have to physically pull the module up, likely, to be able to get to any of its components or wiring to do any testing. So there's a little more of a risk there, I guess, if you might say that. And then on ground mounts too, it's easy to clean. So you could easily stand on the ground safely without being tied off or worrying about slipping or anything else like that, and clean them, or maybe even pull snow off if you have an approved method of doing that, which we'll cover in another subject on the operations and maintenance of a solar power plant. But ground mounts can be a wide range of sizes. Some can be very, very long. Some can be tall. There's different solutions depending on what area you're working with, what kind of system it is. We primarily deal with an all aluminum system, just like with our roof racking. There's carbon steel. There's galvanized steel options out there. They do cost less, but again, you get what you pay for. There's different methods to actually installing the ground mount. There is rammed post, which you have a machine that rams the posts in the ground. The posts are different profile sizes depending on the manufacturer, the design, the wind and seismic, loading criteria, snow criteria, all that good stuff. So, and those can range here between 6 to 12 feet deep that they get rammed into the ground. So what's nice about that is that you have a machine that comes and does that. You don't have, it doesn't really make a mess. You don't have a boring from like when you do pour in place concrete, you have to bore a hole, and you have all the tailings from that, and you have to set the post and pour concrete around it and all that good stuff. So there's more cost associated with that method as well, which I'll cover in a moment. So the ram post stuff for us is probably the most popular. We used to do cast in place concrete years ago It's also pretty hard on the guys. It's pretty labor intensive. It's hard work, and also it just helps mitigate any injuries to our guys. And then the other issue is that you really can't start erecting any of the racking same day. So concrete's setting up, post is setting up, right? So you have to allow time for that to harden so that you can start putting dead loads on there, and then any movement from the assembly portion of it. So that usually entails coming back a day or two later, which just costs more time and money for mobilization and drive time and all that good stuff. So generally speaking, we do it rammed. We can have the post rammed and have the racking all assembled in the same day. Depending on the system size, all the modules and inverters would be mounted the same day as well, but it just kind of also depends on the size of the system and the complexity of it. So there's some advantages there. The few times here that we have done cast-based concrete are some unique designs where we're going 8-12 rows landscape in a system. So it just comes from an engineering standpoint that it is recommended that we do a concrete system. We've done that, or we get into situations where we have a very shallow rock bed, long rivers and stuff like that. Sometimes you only get 3 or 4 feet down and you hit bedrock, so obviously you're not ramming through that. So we'll do cast in place concrete as well. And for ground mounts, they also have a ballast system, so basically it's concrete that is poured above grade. Those can be ideal too for rocky conditions, or in landfills, or even if you want to move it at some point. It's definitely possible to do that. So ground mounts are definitely one of those situations to where there's a lot of flexibility there and many different options. They do cost a little bit more than roof mounts, but you just have to look at the situation and figure out which one is the best one for you. If you have the space and you want to give up the yard space, and you have an asphalt shingle roof, even if you have an optimal azimuth and space, you may elect to go the ground mount for the reasons I just indicated. There's other mounting methods like pole mounts. Those are typically monopoles that are installed, and there's a group of anywhere between 4 to 12, just maybe even 16 modules that can be mounted on those. Now those will be cast in place concrete as well. I've never seen a ram post set up for something like that. Not saying it doesn't exist, but it sure seems like a lot of stress, a lot of loading. If it's going to be 10 feet off the ground and you got a giant sail up there, for lack of a better word, you better make sure that thing's not going anywhere. So you got those, and then they also are available as trackers as well. So you can also get them to where they can track the sun from either time of day or also time of year, or both. So those do cost more than what a roof mount would be, and more than a ground mount would be. So you just look at those benefits. But some of the benefits to a tracker is that it can yield anywhere up to about 30% more power, just because it can follow the sun more in the day, throughout the day, and just yield a little more power. So you'll just have to judge for yourselves if the economics come out for that. They can be mounted on walls, parapets. They have all different kinds of mounting solutions, depending on what you're trying to do. We've done car canopies. They go over parking lots, provide shading for vehicles, carports. So you park camper, your car underneath there and whatnot. So there's all different kinds of solutions. That's for sure. And then you have ballasted roof mounts as well for commercial applications, which would be mainly for flat roofs. They make no penetrations in the roof, and they just use a concrete block to weigh them down so the wind don't blow them off. That's very, very common for commercial applications and for ballast and flat roof systems. So those are options as well that you can take a look at and find the particular solution that will fit your need and make sure that it doesn't void your warranty on your roofs and that sort of thing. So there's all different options out there. You just have to take a look at it. Again, you get what you pay for. There's some pretty cheap systems out there. There's different materials that are available. We're a big fan of aluminum with stainless steel fasteners. Those are going to last, 3-4 decades easy. Versus galvanized steel is just not going to last as long as aluminum. That's my personal opinion. But considering that I have over 30 years experience in the energy business, in nuclear, coal, wind, and solar, I've personally designed and built 180 to 220 megawatt coal plants, and I can tell you that we use a lot of galvanized steel in those facilities, and they do hold up well, but they do corrode and they do fail over time, and they both options depending on what you're trying to do and go about doing it. There's even rackless options, so they don't use any racking whatsoever, and the attachments just go directly to the roof and attach to the module and uses the module itself, the module frame itself, as its racking mechanism. So very intriguing stuff out there, and there's different options. Sometimes we've used the rackless before. One of the advantages to the rackless is that it can be shipped more cost effectively. It can be shipped by any standard shipping company like UPS or FedEx, because it just comes in a box, versus racking. You usually have to come by freight because they're usually 10-foot 8 to 17-foot long sticks of rails. So there's that advantage, plus it's less weight. So it's a little bit less weight on the roof. So if you're doing your engineering and you're kind of on that cusp of maybe overloading the roof, maybe look at a rackless option, and that might help get you in your target there for your dead loads, and without making any roof modifications, or maybe not even doing the project altogether. Maybe look at those options. So hope this has helped you out. You can take a look at our website at any time, www.ecgllp.com. Go to the resources page. We have all kinds of information on solar for you to take a look at, PDFs, videos, to help educate you about solar and the process, and help get you going in the right direction. So I appreciate it.